Hello friends, welcome to this video in our YouTube channel. In this video friends, we shall be looking at the integral we have here on screen. Friends, please watch the video from start to finish, and friends, please make sure you like the video because it does motivate me enough. It gives me the strength to keep this channel growing. Thank you very much friends, and please subscribe to my channel if you want more great content. Thank you so much, and let's dive straight into the video today. Awesome friends, awesome. So friends, the integral simply reads that we should evaluate the integral of the square root of x plus 1 over x minus 3 dx. So friends, please pause the video and give it a try, then unpause it to check the solution. Okay, great. Hopefully you did that. So friends, we'll start by writing this our integral as the integral of the square root of x plus 1 over the square root of x minus 3. Good. So guys, we are going to do a u sub, okay, because all the methods we know in trigonometry seem not to be working so well. So we are going to try to do a u sub. You can let u to be the top or the bottom, guys. It depends on you. It works in both cases. So I'll choose to let my u to be the bottom. That is the square root of x minus 3, guys. Squaring both sides gives me u squared to be the same like x minus 3. Differentiating, guys, gives me 2u du equals dx squared. So friends, my integral now, this integral now translates into, guys, the integral of square root of x plus 1 over u. The x is simply what, guys? 2u du. That's how I have it here. I have my u, which is the value. I let my u to be 3. So friends, at this point now, keep in mind that u and x cannot exist in the integral. They cannot exist at the same time. So one has to give way for the other. In this case, guys, x has to give way for u. Great. So what we have to get an expression of x in terms of u. So this is where we are going to do it. So let's be looking at u squared equal to x minus 3. Our goal is to produce a square root of x plus 1. But let's go bit by bit, guys. Let's start by producing x plus 1. By so doing, guys, we can add 4 on both sides here, right, to get x plus 1. So we're going to have u squared plus 4 equal to x plus 1. Taking the square root on both sides, we are going to have the square root of u squared plus 4 equal to the square root of x plus 1. Great, that is what we wanted to produce. So we are now going to have now the integral of the square root of u squared plus 4 all over u into what times what 2u du. But guys, the u and the u, they can cancel here, right? And we can send the 2 out of the integral. By so doing, we are going to have 2 times the integral of the square root of u squared plus 4 du. Great. So guys, at this point in time, right, the best method for us to use to continue is by using the trigonometric substitution. Keep in mind, friends, that in this case, we have a sum of squares. And the reason we are using the trigonometric substitution is because we don't like the square root. And the only thing that can take away the square root at this point is simply by using trigonometric substitution. And since we have a sum of squares, it's a good thing for us to use the tangent function. So in this case, friends, we are going to let our u to be the same like 2 tan theta. But let's have the original equation. It is simply 2 times the integral of square root of u squared plus 4. We can express this 4 as 2 squared. That's why we're letting our u to be same like 2 tan theta. That therefore means, guys, du gives us 2 sec squared theta d theta. That is where you differentiate tan theta. We have sec squared theta d theta. So now we are ready to take the integral now from the u world to the theta world. We are now going to have 2 times the integral of u is 2 tan theta squaring. That gives us 4 tan squared theta plus 4. Du is equal to what, guys? 2 sec squared theta d theta. Great. That's what we have, friends. Then you can notice that we can factor out the 4 in the square root, right? That is going to give us 2 times the integral of the square root of, we have 4 inside, into what? Tan squared theta plus 1. Alright, guys, let's observe some of these changes. You know that 4 is in the square root, right? And it can come out as what? 2. The 2 can multiply this 2 here to give us 4. 4 multiply this 2 to give us 8. So we are going to have 8 out of the integral. Then, guys, what is tan squared theta plus 1? It is sec squared theta. In the square root gives us what? Sec theta. So we are now going to have 8 times the integral of sec theta into sec squared theta d theta. That's what we have here. So friends, if we multiply out, we are going to have 8 times the integral of sec cubed theta d theta. All right, friends, evaluated the value of sec theta in one of my videos, so I highly encourage you that if you don't understand what I'll be doing here right now, feel free to put your comments, your worries in the comment section down below, and I'm going to get back to you as early as possible. And also endeavor to watch the other video I made, because there are two answers for this our integral. All right, so friends, let's look at it. Let's just evaluate this integral here. Okay, let's keep the 8 aside. Let's evaluate the original integral. Then we can multiply our whole result by 8 to get the value of the integral we want. So we're looking at the integral of sec theta into sec squared theta d theta. So friends, at this point now we are going to be using the integration by part method. So you can discover that we are virtually going to use 3 integration methods to solve this particular problem. Okay, 3 integration by parts and 3 integration techniques to solve this problem. We started with use sub, trig sub, now it's integration by parts. So we are going to use the DI method since that's the easiest. We have our D in this case and we have the I. Guys, which part of the integral should we differentiate and which part should we integrate? Because that's the most difficult part in this integral. At this point, guys, we are going to differentiate sec theta because we can easily do it, and integrate sec cube theta. Differentiating sec theta, guys, let's first of all have our signs here, guys. Let's have the signs. We have positive, negative. So we'll be differentiating sec theta and integrating sec cube theta. Great. So guys, if we differentiate sec theta, we are going to have sec theta tan theta. Integrating sec cube theta, sec squared theta, guys, brings us back to tan theta. So we have it there. Then that therefore implies, guys, this is our integral, which is same like what? Integral of sec cube theta, right? So the integral of sec cube theta, guys, simply turns out to be, we are going to multiply this our diagonals. Multiplying it out is going to give us sec theta tan theta. Then, guys, we are also going to multiply the last row that we have, the last row, and we are going to put it inside of the integral. Keep in mind that we have a negative here, so we are going to have negative of the integral of sec theta. Tan theta times tan theta gives us tan squared theta. Great, so we have it. But friends, what is tan squared theta? It is sec squared theta minus 1. So we are now going to have now the integral of sec theta equal to, we have sec theta tan theta minus the integral of sec theta into sec squared theta minus 1. Expanding the bracket, we are now going to have, here is sec theta. Then expanding the brackets, we are going to have minus the integral of sec cube theta d theta. Then here we are going to have negative, negative, which gives us positive, then plus the integral of sec theta d theta. Great. Friends, what do you notice? If you're vigilant, friends, you see that we have sec theta, sec cube theta this way, right? And we also have sec cube theta this way. So we can bring this guy to the left-hand side, and there's a negative here, so it becomes positive. So we are going to have 2 of them. So we have 2 integral of sec cube theta d theta, guys, equal to just our sec theta tan theta plus the integral of sec theta. Great. Friends, I also have a video where I integrated sec theta, so check that out. But I'll just give you the result here. So, guys, and keep in mind that we have a 2 here, right? We have a 2. We don't want it. We are going to divide all through by 2. Guys, the integral of all of these guys simply gives us 1/2 sec theta tan theta, because we are dividing all through by 2, right? We have 1/2. Then the integral of sec theta, guys, simply gives us the natural log of the absolute value of sec theta plus tan theta. Then since we are dividing by 2 initially up here, so we are now going to have our 1/2. Great. Okay, now friends, at this point in time, we are now going to multiply all through by 8. Since we have to get the integral of 8 of this result, so multiply all through by 8, we are going to have 4 sec theta tan theta plus 4 natural log of our function. Okay, now guys, we are done with the integral. Okay, we are virtually done with the integral. All we have to do now, guys, is to leave from the theta wall to the u wall, and from the u wall we go back to the x wall. Let's do it bit by bit, but you can do it in one step, guys, but I'm going to do it bit by bit for you guys so that you understand very well. Okay, now, so by so doing, guys, let's take one step at a time. Let's record our u was what? 2 tan theta, right? If you divide all through by 2, we're going to have tan theta to be the same like u over 2. Let's look at this right triangle, guys. We need the right triangle. where we are going to have the angle here to be theta. Let's have it here. Here is theta. And tangent is what, guys? Opposite over adjacent. Opposite in this case is u, adjacent is 2. So we are going to have here to be u, and here is going to be 2. Good. Then to figure out what the hypotenuse is, we are just going to take the sum of squares of these other two. So we are going to have the square root of u squared plus 2 squared, which is u squared plus 4. Wait. This triangle now is going to help us now to get all the other three identities. So guys, replacing, keep in mind that our sec theta is equal to what, guys? 1 over cosine, right? Cosine is what? Adjacent over hypotenuse, but 1 over it simply gives us hypotenuse over adjacent. So we're not going to have just keep in mind that we have hypotenuse over adjacent, which is square root of u squared plus 4 over 2. Then tan theta is what, guys? U over 2. So 2 times 2 gives us 4. 4 will cancel with the 4 we have here. So that's why we have just the square root of u squared plus 4. Okay, wait. Then, guys, tan theta, as you all know, guys, is u over 2. The 2 also cancel. Then now plus 4 times the natural log of sec theta is what, guys? Hypotenuse over adjacent. So we have square root of u squared plus 4 over adjacent, which is 2. Then we have tan theta, which is what? U over 2. Great, that's what we have. We now have to leave from this u. Now we go back to x. Our u is equal to what, guys? Square root of x minus 2. So replacing everything, guys, and simplifying, you're going to see our answer to be x square root of x plus 1 into square root of x minus 3 plus 4 times the natural log of the square root of x plus 10 over 2 plus the square root of x minus 3 over 2 plus c. So friends, that is our answer. That's the final answer, guys. Thank you so much for watching the video. Thank you so much, and like I said, guys, please subscribe to the channel so that you will not miss out on any content we have here, guys. We upload very interesting and important content in this our channel every day of the week, guys. You can not have access to them once you subscribe, guys. And friends, please like the video. It does motivate me a lot to keep producing more great contents, and share that with your friends so they can have access to great contents like this, guys. And please, as always, guys, put your comments or your worries in the comment section down below, and I'm going to reply to them before you notice. Thank you so much.